Hello, welcome to this video about verifying with Speakerbench. Essentially what you do to verify is you build a box and you measure the box and you compare your simulation with what you have measured. And to do this, to show you this, we will do that by showing you an example. And in this case it will be this design from SAF Audio, John Krutke. He has this design called ZM-V5, which utilizes a V-Fat tweeter and a small MCM woofer in a box, in an 11-liter box. And Jeff, who is the other half of this Speakerbench stuff, he built this box, and we have used this box to do some measurements so we can verify our simulation with the measurements. First, let me show you the box. It is this little box here, wood veneer port in the front, but small details. That's all within reason. So the first we do is we load this into Speakerbench, and normally what you do with your driver is you measure the driver to define the parameters with this fit, and then you create a little data sheet for your driver so you can use it for simulation. But in this case with the MCM we already have it and we can just import the data sheet. So we will do that. We will go to this import tab and select this MCM 553870 driver, which is used in the SAF audio design. It's imported and we go to the box simulation, and this particular design, the box is 11 liters and the port tuning frequency is 49 Hz. So we pick that and push the apply button. This is the simulation, and frequency response and impedance. And we keep these losses very high for a start. And so the box is built, we measure it's easier to measure the impedance because measuring frequency response at low frequency requires a very long window or an anechoic chamber or something like that. So let's import an impedance response measurement. We have this for the box, which is empty, which means there's no damping material in the box which aligns with this. And we push the apply button to import the data, and then we look at the impedance. And we can see it's not far off, but there are some minor differences, most notably here at the lower frequencies, which is due to losses in the box, even though the box is empty, meaning without damping material. But there's a leakage loss in this design, and I've done a little bit of homework, so I know that if we set the leakage to 20, which is a good place to start, it'll come much closer. And we can see now that it matches pretty okay. We might be able to get this down a little bit if we also apply some port losses, so let's try to do that. This comes up a little bit due to port losses, so we will set port losses to 50 in this case and see what happens. And now we can see that it's a pretty close match. This means that at least for now, without damping material, we have a pretty good model for what goes on in this box. So that's basically how you work with verifying your simulation with measurement data. In the case of frequency response, is a little bit more difficult, but Jeff has actually measured the port output at very close range. So you basically go in with your microphone in front of the port opening and measure the response. So let's have a look at that. This is this port measurement in a box that's empty without damping material. We push the apply button, And we can see here that, whoops, the empty port box is imported, but it comes out at a very high level, obviously because we are measuring at a very close distance and the simulation is for standard 1 meter. So we can try to adjust this, and we have inserted the opportunity to put a gain adjustment in. We can see here that we have about 125 decibel and the simulation is around 85, 86. So I can go back to my settings tab and I can put a gain adjustment of -38 in and see what that looks like. When we go back, we can see that that's an okay match, I would say. We can see that it falls off a little faster here, very little, and maybe there's a little more output over here, but generally speaking it's the right trend here. We have here at 100 Hz 75, 74. There is a decibel difference here, and this is how we verify that Speakerbench is doing the right simulation. But obviously the feature is available. You may as well also use it to verify your specific build. By the way, now that we have it loaded, I talked about it in another video that there are different models available in Speakerbench. This is a TNet model which uses transfer matrices to do the calculations, and this is one of the reasons why this looks so nice. If we go back and pick a lump parameter model, we will be able to see why this is a less good choice. We can see here that if we pick the Futtrup model, which is a lump parameter model that includes damping material, we're not using it right now, but we can see that a classical lump parameter model will have a notch here somewhere. And obviously when we do the measurement, we can see that that's not what happens in real life. And basically that's why we have improved on the modeling side, so that we don't have these artifacts in the simulation. But a lot of simulation software out there will have such a notch because they are lump parameter based. And one trick to get rid of it is just to raise the bottom of the graph so you don't see it. But we can go back to the TNet model, which is our recommended model. And by the way, we can see here that Speakerbench is predicting the first box mode here, and we can see here that the port output at least has some additional output here. The port model in Speakerbench, it also supports instead of a simple model, it supports a transmission line model. And when you have that simulated as a transmission line, you can see the tube resonances in the port. In this case, it's a 2-inch port, and we can see that that's not too far off actually. That we get a simulation here that shows some port output. So this is how we verify, and certainly you can also verify your designs by importing and comparing measurements with simulations. And once this all fits, I think it's pretty safe to say that that Speakerbench is doing a valid simulation of the real situation with the correct amount of output and the correct amount of, let's say, power draw from the amplifier, because the impedance is correct, and you can trim your damping factors so that you are really close to your simulation is really close to the real box that you have built. And of course this graph here with the roll-off will be a lot more accurate than what you can measure. Especially if you have a multi-way design with several woofers and so on, it can be really complicated to measure and get a valid result. But in Speakerbench it's pretty easy to do the simulation. Thank Thank you very much for watching. I hope you like these videos, and if you do, please give it a thumbs up, and please subscribe to our channel. Take care.